Today, we start with chapter 2 of class 11 textbook. We have chosen some key concepts from this chapter and we shall deal with them one by one. Today, we deal with SI system of units. You know, the basic purpose of all sciences is to understand the natural phenomena that occur around us. Another purpose could be to use this knowledge to modify some of these phenomena to the advantage of mankind. For example, if you can understand weather, then we can use it sometimes for our purpose. We can modify it and use it for our advantage. Among all branches of science, physics perhaps is the most fundamental. It is a foundation on which rests the structure of other sciences such as chemistry, geology, astronomy and biological sciences. In science, as you know, in physics in particular, we wish to make as precise measurements as possible. Several times in the history of science, precise measurements have led to new discoveries or important developments. Look at this example. Just think, if we had not measured the speed of light as precisely as we know today, 2997992,458 meters per second, and had not been able to measure the distance of the moon as accurately as we do today, would we have been able to put a man on the moon? Remember that for launching and for the journey of the satellite, for the astronaut to descend from the satellite and then to join back, each microsecond is important. If we are not accurate to that level, space missions will not be successful. These days, you know, lunar laser ranging experiment gives the distance of the moon accurate to millimeters. Example 2, you must be hearing of this new and exciting technology of today called nanotechnology. The name itself suggests that we are working with systems of nano size, that is of the order of 10 to the power minus 9 meters. It is being seen among other things as the future of medicine and well-being. It is enabling us to deliver drugs precisely where they are needed. Diseases which are benefiting include cholesterol control and cancer. The laws of physics are expressed in terms of physical quantities such as distance, speed, time, force, volume, electric current, etc. These quantities must be measured and expressed in standard units. Why? Let us answer this question. Let me illustrate with this by an example. Suppose you undertake an investigation on the solubility of a chemical in water. You weigh the chemical in tolas and measure the volume of water in cupfuls. After the investigation, you write the results to a scientist friend in Japan. Would your friend be able to understand your results or be able to reproduce them in his lab? The answer to both these questions is no. Remember that in science, the results of any investigation are considered established only if they can be reproduced by investigations conducted elsewhere under identical conditions. Not only scientists, industry, commerce and trade require that units used be internationally agreed. So, with the need of agreed units internationally in mind, the 14th General Conference on Weights and Measures in 1971 adopted 7 base or fundamental units. These units form the SI system of units. This table shows base units of the SI system. They are length, the unit of which is meter, and the symbol is m. You see, in the first column there are quantities, in the second column there are units, in the third column there are the symbols for these units. So, we have length, the unit of which is meter and the symbol of which is m. We have the quantity mass, the unit is kilogram and the symbol is kg. Then we have time, the unit is second and the symbol is s, small s. Electric current, the unit is ampere and the symbol is capital A. Temperature, the unit is Kelvin and the symbol is capital K. Luminous intensity, the unit is candela and the symbol is small c d. Amount of substance, the unit is mole and the symbol is MOL in small letters. I would like to draw your attention to the third column in the previous table, where we have given symbols. M, for example, is a symbol. It is not part of any language. It must be written as such. Distance must be expressed in m. In some places they write meter in their own language. For example, some states in Hindi would write it as meter, me. That is not acceptable. For scientific purpose, the distance must be expressed in m. In fact, in all languages the symbol of meter is m, not even m dot, and the symbol of centimeter is cm and not c dot m dot. Similarly, small s is the symbol of second. In all languages it is so. SEC or S dot are wrong, they are not acceptable. Similarly, kg is a symbol of kilogram, g is a symbol of gram. Written in any other way such as gm, they are wrong. Capital A is a symbol of ampere, AMP, which you might find in any books, or any other variation is wrong. We must obey these rules whatever language we may be using for learning. Another advantage of SI system is that it is a metric system. They are quite easy to handle because the smaller and larger units of the base units are always multiples of 10. These multiples or some multiples are given special names. The common among them are giga, which stands for 10 to the power 9, mega, which stands for 10 to the power 6, kilo, which stands for 10 to the power 3, milli, which stands for 10 to the power minus 3, micro, which stands for 10 to the power minus 6, and nano, which stands for 10 to the power minus 9. Examples are gigahertz, frequency is measured in gigahertz, you know. Megawatt, power is measured in megawatts. Kilometer, distances are measured in kilometers. Milligram, very small amount of substances are measured in milligrams. Microampere, small amounts of currents are measured in microamperes, and very precise times are measured in nanoseconds. Besides the base units, all the units that we use are derived from them. The derived units also have special names and specified symbols. Some commonly used derived units are listed in the following table. Again, look at this table very carefully. The first column is quantity, the second column is the name of in which that quantity is measured, the third is the symbol, and the fourth is the dimensions of that quantity. Remember, I have listed only those quantities which are used in mechanics. When we come to electricity, we will introduce other quantities also. Force is the first in this list and its unit is Newton with small n. It is named after the great scientist Isaac Newton, and its symbol is capital N, and its dimensions are kilogram meter per second square. Let me emphasize, Newton If you want to write 10 newtons, you will write with small n, or you will write 10 capital N. You must always obey this system. Pressure, the name of the unit is Pascal. Pascal, you know, was a French scientist, and Pascal is written as a symbol with small p, and its symbol is capital P small a, pa, and its dimensions are Newton per meter square. Energy or work, the name of the unit is joule with small j, Joule, and the symbol is capital J, and its dimensions are Nm. Power, the unit name is watt, again named after the great scientist Watt. You know, the name watt is in capital W, but the symbol for power is with small w to distinguish it from the name of the scientist. Although it is named after the scientist, but it must be distinguished when we use this as a unit. So, power, the name of the unit is watt, symbol is capital W, and dimensions are joule per second. Let me emphasize once again the correct usage of symbols. 10 capital N or 10 Newton with small n for force are both correct. Any other variation is wrong. Similarly, for work, capital J or joule with small j are correct. For power, use capital W or watt with small w. Let me emphasize also one more thing. There are several countries in which people still use miles, feet, and pints for volume and so on. But remember, the scientists of those countries always use the SI system of units. For scientific work, SI system is the only system that is used throughout the world. So, therefore, you must get used to using this SI system. This was about units. I think I have emphasized many things. For example, the symbols of the units to be written correctly, and then derived units and their names and symbols to be written correctly, and so on. In the next lecture, we shall deal with dimensions.